Hello, I am Slavko Žitnik and I will moderate this session on text semantics and text mining. So today we have three presenters, each around for 10 minutes. And at the end of the session, we'll have a Q&A session. So I invite you all to cooperate and to use Slido to ask questions so that you will get your answers at the end of the session. So text mining and semantics is gaining quite a lot of interest, and it's important because of there is enormous amounts of data available that needs to be extracted and knowledge bases needs to be created. And this is a topic we'll talk about today. So the first presentation is titled Implementing a Semantic Analysis Pipeline for Public Sector Documents. And it will be presented by Professor Blaž Zupan and Mr. Miha Jesenko. Professor Blaž Zupan is a well-renowned researcher in the field of artificial intelligence and machine learning. He's the head of bioinformatics laboratory, which develops Orange Data Mining Toolkit. And Google enlisted Professor Zupan as one of the top 100 most influential innovators of the Central and Eastern Europe. Together with him, Mr. Jesenko will take care about data governance at the Ministry of Public Administration of Slovenia, and he will introduce new technologies to be used by the public sector. So please, Professor Zupan and Mr. Jesenko, stage is yours.
Thank you, Slavko. I'll start and Blaž will continue. Today I'll talk about, hello everybody. Today I'll talk about a project in public administration involving artificial intelligence. It's the development of Semantic Analyzer. If maybe slides could come up, it would be a good. Okay. I think next slide, please. And another next slide, please. Yeah. Semantic Analyzer applies various AI techniques to find interactions between words and to thus analyze and describe each document in a collection of text. In public administration, we are daily confronted with heaps of documents and texts. We have to sift through and find a few relevant ones according to our information needs. This is true in various kinds of our work, whether in different processes of preparing legislation or strategies or policies, in preparation of different evaluation reports or preparation of other kind of reports, and the list goes on and on. Semantic Analyzer shows contexts of a collection by clustering text similar in content. We can then further explore these contexts by selecting groups of texts, see what they are about, where there are bigger and smaller group of similarities. We can also explore whether there are any duplications, overlappings, and so forth. Semantic Analyzer, we have various types of documents. Semantic Analyzer could make semantic relations between such types. For example, with legal texts, we could have selection of texts based on certain content from legislation, preparatory acts, case law, supplementary acts, literature, and so forth. Semantic Analyzer offers easy interaction tool, friendly user interface to work with multiple collections of text, either to be used to find and update ontological terms from a collection of text, or to use a text or a few texts from one collection and semantically search through another collection. Semantic Analyzer mostly saves time. Leaping through many large documents takes time, even days sometimes. Dealing with semantics, dealing with content, Semantic Analyzer can narrow down relevant text from possibly even hundreds or more to just a few. It also offers quick previews of content, different contents in a collection. We can explore which topics are more or less represented and what kind of similarities, how homogeneously or heterogeneously the topics are represented. Okay, next slide, please. Semantic Analyzer is a project within larger project called Technical and Semantic Renovation of Base Registers. Semantic part of our project also deals with introducing semantic interoperability in public administration in more methodological manner. Semantic Analyzer will be used to help in our work with control vocabularies of public administration and base registers. Project is a joint work of our Ministry for Public Administration and Faculty for Computing Informatics at University of Ljubljana. Blaž team is closely involved with data analysis and mining tool called Orange. Since base registers in Slovenia are regulated by law, we chose as the first collection to be Slovenian laws. Soon we saw that Semantic Analyzer could be used in relation to legislation in many ways, but also applicable, similarly applicable, mostly applicable to other collections as well. Also encouraged by you, data strategy, we launched an idea of legislation data space. Of course, data space is not just a collection of text and tools. It has to follow certain data governance, interoperability governance rules and principles, so to be reliable and trustworthy. Next slide, please. The development of Semantic Analyzer is not yet finished, so we chose to show one possible use of a tool. The case is linked to legislation. Our government has a website where everyone can propose and describe an issue to be solved. Let's now take on a role of someone who prepares answers to such proposals. We'll be working first when we get when we get a new proposal. We want to know where, if in our collection of proposals there already been such a content. If not, we have to look for an answer in laws. So we'll be doing here with two different collections of texts visualized as two document maps of laws on the left and maps of proposals. Each circle represents a document. The closer the circle, the closer the documents. Okay, now let's say that a new document has arrived, has been posted. It's titled Proposal for Lenient Penalties of Bikers Under the Influence of Alcohol. We feed it into a tool, see where it is. It has been clustered in a maps of proposals. That's that arrow you can see. Then we have to zoom in to see if there are any similar proposals already in our collection. Next slide, please. Here we can see that partial similarity has been found with proposals of educational sanctions for drivers. Here you can glimpse at result of Semantic Search, where Analyzer tool has found similarities in content between lenient penalties and educational sanctions. But it is not enough for our case. We have to go look further in laws. Please, next slide. But characteristic terms of a proposal are now used to search semantically through another collection of laws. The most relevant laws for our proposal are visualized on a map of laws with big yellow circle. From here, we can also browse through content of most relevant laws, and soon we'll be able to browse through the most relevant parts of the most relevant laws. Okay, this is the end of my part. Blaž, we continue. Thank you for your attention. Goodbye.
So what was shown was actually a way of visual programming. So the way we analyze these documents and compare them is through constructing workflows. Workflows are made from components that do certain operations like, I don't know, read the documents, pre-process text, construct bag of words, and then, I don't know, map documents via t-SNE visualizations and so on. And the idea here is that if you have a set of components like that, you can analyze you can construct any kind of workflows that deal with your documents and that combine interactive visualizations with any kind of data analysis. Next slide. The idea in this project was to actually figure out how many blocks how many computational blocks do we need for semantic analysis. And here on this figure, you see that there are like rather a few. There are like some core processes in data analysis that can be that we can combine them in order to get desired results. Like I don't know, we can use components for visualization, maps, data reduction, keyword extraction, and then we can also use other components for classification, clustering, and other kinds of visualizations. The point is that the minimal set of components or bricks that we use in such workflows is not large. It's on the order of, let's say, 100. So it's fairly easy to learn and train the users to use them. Next slide. The advanced features that we are building for this semantic analysis are, for example, automatic construction of ontologies. So the idea here is that based on the keywords that we extract from the text, can we augment the ontologies? Can we then use the ontologies in data analysis? We aim also at explainable visualizations, and we wrap everything in a way that we can train the people that are the end users of the system easily, right? So here I should say that the end users are not really the final end users, because the system that we are building is designed to pilot particular applications and to discuss their utility and the methods to include. And based on this, actually, then the dashboards and websites are constructed. Next slide. What was shown was built in a tool that has been developed by University of Ljubljana. The tool is called Orange, and its advantage is that it's completely free. It's a very large project, about 1 million lines of code in Python. And the add-on that we use for text semantics and semantic data analysis, it's freely available on a website. Next slide. So with that, we thank you, and I think that questions are at the end of the session. Thanks.
Thank you for your presentation. So we now go to the second presentation, and as Professor Zupan said, please ask questions using Slido, and we'll check them at the end. So our second presentation is titled Hurdles for Semantic Interoperability, Lessons Learned from Spanish Public Authorities. The speaker is Dr. Ana Rosa Guzman, Head of Unit for Interoperability and SDG. She has more than 20 years of experience with information systems and is Spanish representative for public administration. She coordinates the adoption of the Single Digital Regulation in Spain and is active in several European initiatives focused on public service digitalization, standardization, and interoperability. Please, Ana Rosa, take it away.
Thank you, Slavko. Well, I would like to tell you about the human factor of the semantic interoperability. So the presentation, please. Next, please. We all know the semantic challenge. The meaning of a concept may change because cultural, sectoral differences, but also regulations provide different meanings for the same concept, and meanings used to change over time. Next. As a result, next, please. Yes. As a result, this is a bubble tower with an ambiguous sharing and of meanings. So semantic interoperability is about human understanding, so we need to focus on the human factor. But also humans provide meaning of the meaning context by regulations in the public sector. So we need a mutual understanding in this sector, in the public sector, to benefit our citizens and businesses. Next, please. The Spanish context is quite complex. We have different administrative levels with 22 ministries and many autonomous bodies at the national level, also 27 regional governments and 50 public and 33 private universities, over 8,000 municipalities distributed in 50 provinces. And we also have the Spanish and other 4 regional co-official languages and a great cultural diversity. Next, please. So our semantic interoperability relies upon 2 sound pillars: legal grounds and collaboration and cooperation governance. Our national interoperability framework was approved by Royal Decree in 2010, sorry. Our legal framework includes duties on collaboration and cooperation, as well as created governance structures, and includes specifically semantic interoperability provisions, such as the publication of catalogs, reuse of semantic assets, and to incorporate the semantic interoperability agreements as part of the interoperability technical standards. And we have created the Sectorial Committee for Digital Administration that reunites representatives from the central government, the regional governments, the Federation of Municipalities and Provinces, and the Conference of University Rectors. It has periodical meetings, so it is a sharing space to share experience, concerns, best practices, and it is also a decision approval that relies on the creation of thematic working groups. Next, please. So we have several working groups dealing with semantic interoperability, like the ones with intermediate data services, the implementation of the ones only in our country, open data, metadata on the electronic files, documents, archives, etc. We have a multidimensional approach. These working groups tackle legal, organizational, semantic, and technical issues. And it is also counts with multilateral experts from the domain and from the specific domain, and also semantic experts. Next, please. Regarding SEMIC initiatives, we believe that it plays three roles. On one hand, it is a drive for our semantic initiatives. The SEMIC initiatives provide core vocabularies and domain-specific ontologies that boost our own work. Also, we need SEMIC initiatives because building the single digital market needs a common understanding. So interoperability by default, and specifically semantic interoperability by default, is critical for building this single digital market. And the third one is that semantic initiatives should comply with a strong requirement, because we don't build a semantic interoperability from the scratch. So there are systems, semantic specification and information systems, that is a strong requirement for the SEMIC initiatives. Next, please. Let me show you, talk to you about the one success case in Spain. It's about the ELI, the European Legislation Identifier, which is a European standard for the identification, description, and information exchange of legal information published in the official diaries and databases of the member states. In our context, we have different official gazettes managed independently, the State Official Gazette, 17 autonomous official gazettes at regional level, and 43 provincial official gazettes. We have multiplicity of legal information systems and a multilingual context, as I previously told you. And the approach tackled here was first a collaborative process by means of a specific governance structure within the sectoral commission for digital administration explained before, with a dedicated working group, a common technical document with the minimum guidelines, and a flexible model suitable for the three administration levels. This was really important for us. So in the first stage, we tackle with the state and autonomous legislation, and in a second stage, we tackle with the local legislation. Next, please. Then they produced the implementation model based on the three pillars of the ELI template for URIs. They created the same URI template for all the legislation, and public authorities responsible also identified by the ELI jurisdiction. In the second pillar, the ELI ontology for common metadata, discriminant legislation. They elaborated a control vocabulary and interoperability core with a minimum set of common metadata, which each entity is free to apply with the other metadata according to its needs and situation. And the third pillar, publishing and siren, was accomplished by a common web page as a collaborative effort, which is elidata.s. Next, please. So, which are the learned lessons? First, to achieve actionable agreements is required. It means that we need legal grounds to support the creation of these agreements. We need also permanent and ad hoc collaboration cooperation structures, in our case, the sectoral commission and the working groups, and multilateral and multidisciplinary participation. The second important point is that semantic agreements are hard to achieve for several reasons. First is even the most popular concepts may be understood differently. For instance, we can think that a very common concept like a person could have a common understanding, but it is not, because it depends on the context, it depends on the legislation. So we need to care this aspect. Second, the information representation in place is hard to adapt, because we need to reconcile many existing information systems. We cannot transform the information system which is based on the semantic interoperability. So we need to incorporate them in our semantic agreements. Third, legal regulations impede for matching. In Spain, the same concept has been implemented by different regional, local, or national legislations with different slight differences that need to be identified and also incorporate. Then also that the return of investment is necessary to prove utility. Semantic agreements is not needed because they are good to have, but because they are useful. So we need to prove the utility. And finally, domain and semantic experts need each other. Semantic experts are there to help to creating these semantic agreements, but without the knowledge of the domain, it is impossible to produce a good outcome. Next, please. So we believe on an incremental and practical path. So the first step is to start with the most demanding critical use cases. We have many use cases to tackle, to manage. So we need to identify which are these most demanding critical cases. Second, we need to work on core agreements to be expandable under specific needs. The third step is to prioritize actionable solution over perfection. This is because perfection takes time and it is more difficult to achieve. So we need to be practical. We need to prioritize actionable solutions, actionable agreements. The fourth is that we need to give time to consolidate solutions. Yes, we are in a hurry, but a baby needs 9 months, and in this regard, it's very similar. We need time to consolidate solutions. And in the fifth point, this is also the base for get onboarding with success cases, because if we have time, if we prioritize actionable solutions, if we work on core agreements and the most demanded critical use cases, then we have success cases that can be the tractor for the onboarding process.
Excuse me, Anna Rosa, we are past 10 minutes, so
yes, this is the last word. Yes, thank you.
Thank you.
And finally, we need to refine the solution when needed, because there are much work to do, so we need to rationalize our efforts. Thank you very much.
Thank you for your presentation. Sorry to bother you almost at the end. So we have one more presentation left. I also invite you all again to ask questions using Slido. Please use hashtag SEMIC2021. And our last presentation is titled Extracting Semantics from Legal Text, a Visual Exploration of European Case Law. It will be presented by Dr. Veronika Haberler, CEO and co-founder of the legal tech company Lereto, which develops innovative legal research solutions. She's mainly involved into innovation, legal tech, and data analysis. Please, Veronika, stage is yours.
Thank you. So, excellent. So this presentation is about visualizing case law using Eurolex data. We are all about working with digital legal texts and documents and finding new ways to work and interact with legal information. Today I will present our winner project from the EU Datathon 2019, the Smart Files Network. So, excellent. We were interested in finding new ways of working with legal documents aside from just reading the text. At the same time, we had the intention to create something that is not only limited to a certain jurisdiction. The EU Datathon is a competition where the participants have to develop a prototype within a few weeks by using European data sets. Our contribution was a visually appealing and useful interface for legal network graphs to show the context of legal documents. We did this by making use of existing metadata with open databases like Eurolex and given references within documents. When combining these data, we worked with network analysis methods, real-time analysis, and rendering technology. I want to start my presentation with the basic question, why does it make sense to focus on case law citations when extracting information from legal text? Case law citations are of utter importance for the interpretation, comprehension, and application of legal text. So we find them in a lot of legal documents and, of course, in case law decisions. Further, these citations build a meaningful network and thus meaningful context for legal knowledge work. Case law citations are quite standardized across Europe, as you can see here. This is true, although not all legal knowledge workers use the European case law identifier, but the case law number, which isn't a true ID, but works in much cases as such. Case law references are international, so you have the advantage that you won't need to worry regarding language-related challenges. And because case law references are common in practice, also sufficiently standardized and especially relevant, we chose to focus our project on that. Our approach was dedicated to user-centered design. As legal professionals are heavily document-focused, we also concentrated on the document as a starting point. While we already had some key technology for the project up and running, it was our first time for us working with Eurolex data and visualizing data in Citation Network Maps by using network analysis methods. Next, I will tell a bit about the data and technology used, and we'll, of course, do a presentation of the features that we created. We used Eurolex and national case law data sets and the Euroc thesaurus. Most important metadata for our apps were the case law identifiers, the ACLI and the case number, the URLs to web and PDF content, and the subject matters or classifications. First, we collected 76,000 case law decisions from Eurolex and a few thousands from LIS. Then we used our knowledge framework technology to extract information, enriching the plain PDFs from Eurolex and this with source links to case law, and we calculated the in and out degrees of the case law decisions. So let's take a tour through our tool. That's the start screen of our page before starting the visualization of our PDF. You can do a PDF search to recognize and visualize case law. This is done via drag and drop or the file explorer. After the analysis, there are four main elements in our interface: the landscape and citation network map, the interactive data overview, the case law info box, and our checkout options. Let's start with the citation network map. That is a knowledge graph based on the cited case law. The red icon shows our analyzed file. It is in the center of the network shown. Then you see the nodes representing the cited case law in the PDF. A light blue node marks a first level citation, while a darker blue stands for a second level citation. The edges are the connections between case law. There is an animated particle flow to indicate the direction of the connection between two nodes. And the node size indicates the relevance within the shown network of first and second level citations. But if you hit the relativity switch in the top right corner, the node sizes change and now represents the relevance within the whole EUROLEX case law data. Some nodes get smaller and some really big, as you can see here. So you get a totally different impression of the context of your PDF. And in our example, the big nodes were competition law and state aids cases, which obviously are more often cited than the smaller ones. Like the ones in the right corner, which relate to procedural topics. So we have a list of first level citations, then the generated network analysis data, where the integrity is a value representing the relevance measured by the amount of citations of the decision within the EUROLEX network, and therefore that value can change over time, of course. The out degree shows the case law fundedness of a node. That means how many EUROLEX decisions are cited within. The out degree is a constant value as it won't change anymore after the publication of the decision. And then there is a list of the top subject matters of the citation network and filter and highlighting options. If you're especially interested in the shown case law decisions, just click on the node and open the node info box. You will find case law metadata of the selected node, the link to EUROLEX, metadata like the case number, the TLEX, the ECLI, the date, title, and national code. The subject matters of the node, they can and mostly will vary from the top subject matter selection on the right. And you can start a subject matter search at EUROLEX by clicking on a listed subject matter. So to give you a better impression of the application, I've brought a screen capture with me. First, we start the real-time analysis of our PDF and wait for the visualization of our citation network map to show up. You can explore the network by clicking on the nodes, and by hitting the relevance button, you get the citation relevance within the whole EUROLEX dataset of case law decisions. And on the left side, we have our filter and highlight options. By hovering over the sidebar entries, you can highlight a case law node or all cases with a specific subject matter, and you can filter the network by date with the slider. We implemented a semantic search feature that allows to start further research directly from an analyzed PDF. For that, we used the multilingual EUROVOC thesaurus. Our semantic search identified the key concepts found within the analyzed PDF. And with these concepts, you can start further researches in legal databases like EUROLEX or LIS. I would also like to mention that we have implemented language recognition in our PDF analysis workflows to choose the preferred language settings for the search in EUROLEX and apply the right key concepts from EUROVOC. Let me quickly introduce you to the main elements of our semantic search. The search areas here in the top section, the search features cross-database search with found and selected concepts. Below, you find the section with the extracted and related key concepts of our analyzed PDF. In our example here, the concept consumption was found, here shown with a blue label. It is displayed in the hierarchical structure of EUROVOC, where every concept is embedded as broader, narrow, and related terms. So one can start the research itself by choosing from the concepts and combine them. And even add keywords by typing in the search line. Then hit the search buttons to open the desired databases in new browser tabs, for example, like you see here, EUROLEX. So, well, that's all. I hope you enjoyed this showcase from the legal world. Thank you very much.
Thank you for your presentation. In the meantime, we got some questions. So maybe we start with a question for Professor Zupan and Mr. Jesenko. So in your presentation, you already presented who is the tool meant to be used by, who should be the end user. And now we are interested in how complex is the tool that you have presented for the users that are not from the field, or for the users that are not computer scientists.
Maybe I can answer. So Blaž, Zupan here. So Orange is actually intended for the users who are not computer scientists, but did master some of the data analytics or data science topics. The tool is actually meant for piloting, prototyping the solutions, and it's not the tool for the end users, those that use the tool every day at the end of the pipeline. We thought that this is beneficial because the utility of semantic text analysis in the public sector is still a completely open field, and we are not at the stage where we understand everything, and we are at the stage where we can actually plan and evaluate the utilities of these technologies in the sector. And so the end user is the end users are thus a combination of data scientists, end users with the data, who will actually design the final solutions.
Thank you. So this tool, of course, is use and exploration and use of existing techniques to explore textual data. So we have some questions related to semantic definitions. So let me ask Dr. Ana Rosa, where are the semantically interoperable definitions stored? Is there a national data warehouse or something similar where this data is stored?
Yes, in our national interoperability framework, there is a provision for the creation of a semantic a center for semantic asset traceability. So we have a catalog with that reunites all the semantic asset created by our public authorities to free reuse by them, and some of them free reuse for everybody. So yes, we have that catalog at the national level, which is federated for the catalogs that can exist in the different administrative levels in Spain.
Thank you. And now we have a question for Dr. Veronika. So you were aiming at legal professionals and visualization of legal citation networks. Is there any use case also for other knowledge domains, or can your tool be somehow used for other data?
Practically, yes. We think that every professional domain with a habit to cite frequently could potentially benefit from such a technology. But of course, it depends on the data that is available as public, or how the quality of the data would be to work with it. But yes, there are a lot of potentially interesting fields to apply that technology.
Thank you. We have another question for Dr. Ana Rosa, and someone is interested whether do you collaborate with academia in Spain and or private companies to support interoperability and semantics?
And our Sectoral Commission for Digital Administration has representatives from the rectorate of the universities, both private and public universities. So they are part of our governance structure. And regarding the private sector in general, besides working groups, we also create specific forums for thematic forums when we are producing solutions that cover both the public and private sector, like for instance, the EM voice. So yes, we have a collaboration from the university directly and from the private sector through these forums.
Thank you. Now I may ask again Professor Zupan and Mr. Jesenko. So you presented that freely available tool that anyone can install and use techniques that are available inside. So the techniques that are implemented there, so I believe there are state-of-the-art technology that someone could easily use and visualize data. Does the end user need to have some special hardware or computers, or is it enough to have a laptop computer to run this analysis?
Depends on the size of the data, but for example, the case that was presented briefly in a talk was the sufficient equipment would just be a laptop. So some part of the analysis, of course, with deep networks and keyword extraction run on servers, and I mean, Orange communicates with servers for those kind of analysis.
Okay, thanks. So that's great. So if you have small amounts of data that you can process locally, you can work locally. Otherwise, as I see, Orange also allows for computation in cloud. That's great. If I continue with challenges in text analysis, and I ask Dr. Veronika, whose focus lies in legal knowledge domain. So are there some special challenges in legal domain comparing to other domains, let's say processing news articles, sports events or something like that, or maybe Twitter data? What is the main difference?
Well, I can just say what we found quite tricky and challenging in our project, but I think what is definitely a problem within the legal domain is that we have a lack of published open data of court decisions. So there's still much room for improvement in most member states, I would say. And another challenge are the homonyms within legal documents. For example, legal concepts can vary from country to country. Like Stiftung, which would roughly translate to foundation in English, under the laws of Austria is totally different from the concept of Stiftung in Germany. So you would need to keep that in mind and have data sets from your legislation, because otherwise you can't really automate the semantic extraction here. And legal concepts are always fluid, and that is why it is so especially important to team up with local domain experts when working with legal information.
Thank you. Yeah, so obviously still at the end we come to the data and current state of technologies. And as we have heard today, all of you develop technologies that help to organize unorganized textual data to knowledge bases and to extract some knowledge for inference to be used somewhere else. So we came almost to the end. We still have 1 minute. So I would like to